we get started, I'm going to review what it means to be a perfect square. So, if I have 5 times 5, what does that equal? 25. This number is a perfect square. If I take the square root of 25, I get 5. That's what it means. 5 times 5 is 25. So the opposite of that, taking the square root. If I have 7 times 7, what do I get? 49. Which means that the square root of 49 is what? 7. We'll do one more. 10 times 10 is 100. Which means that the square root of 100 is 10. Now let's throw in some variables. What is x times x?
X squared.
X squared. So that would mean that the square root of x squared is what? X. Okay. What about x to the third times x to the third? That is what? It's x to the 6th. Remember, when you multiply variables, you add the exponents. So what that means is that the square root of x to the 6th is what? X to the third. What if I have x to the 10th times x to the 10th?
X to the 20th.
That's x to the 20th, which means that the square root of x to the 20th is x to the 10th. Okay. So if you can take the square root, it's a perfect square. Alright, so in order to be a perfect square, when we're talking about variables, notice all the ones that I did here, the exponent was even. It has to be divisible by 2. So when we're looking at variables, not just regular numbers, we're only looking at variables. For it to be a perfect square, the exponent must be divisible by 2. So let's go over here on the side and look at these again. If I'm asking for the square root of x squared, you're going to divide that by 2. All of these, we just divided them by 2. Oh, you can't see that. Divided by 2, the exponent. So what's the square root of x squared? What's the square root of x to the 10th? X to the 5th. The square root of x to the 16th? X to the 8th. The square root of x to the 24th? X to the 12th. Alright. So when we are factoring, one of the, what we call kind of a special case, it kind of has a shortcut formula, is called a difference of squares. What does the word difference mean? In math, what does it mean? It's subtraction. Difference is when you subtract. So when you subtract 2 perfect squares, we have this special formula. Now your perfect squares, your numbers, we did these a lot in quadratics, like 4, 9, 16, 25, 36, 49, 64, 81, and so on. Those are perfect squares. So any of these numbers, any variable that has an exponent that's a multiple of 2, those are considered perfect squares. So when I'm subtracting 2 perfect squares, we have this special shortcut. So if I have a squared minus b squared, I have 2 different squares and I'm subtracting them. Here's the rule. In one parenthesis, it's a plus b, and in the other, it's a minus b. And I will explain that with an actual example. It'll make it easier. So in question number 7, I have a difference because it's subtraction. And then x squared is a perfect square. Is 25 a perfect square?
Yeah.
Yes, it's a perfect square. So we have a difference of 2 squares. So this right here, that's like my a squared. That's like my b squared. And what I'm going to do is I'm going to take the square root of each of those. And that's going to become my a and my b. So my a, I'm going to do the square root of x squared. So you do the square root of the first thing. And what is the square root of x squared? X. Good. My b, I'm going to do the square root of 25. Just ignore the minus. Don't bring the minus down. What is the square root of 25? 5. So when I factor this in one parenthesis, I'm going to do a plus b, which is x plus 5. And in the other, I'm going to do a minus b. So x minus 5.
That's all you do?
Yep. And you'll see in your calculator, if I check x squared minus 25, I get that number. And if I try x plus 5, x minus 5, I get that same number. So I did it correct. Kind of like having, if I told you you have the number 21, that's the number 21, but you could also write it as 7 times 3. That's essentially what we have here. This x squared minus 25 is the same thing as the x plus 5, x minus 5, just written a little bit different. Okay. All right. So number 8, for my a, I'm going to take the square root of x to the 6th. It's what?
X to the 3rd.
X to the 3rd. Good. For my b, I'm going to take the square root of 64, which is what? 8. And so my answer is x cubed plus 8 and x cubed minus 8. It is okay if you do the minus first and the plus second. That's fine. What you cannot do is switch the 8 and the x cubed. But if you do the plus, if you put a minus here, 3 times 5 is the same thing as 5 times 3. Number 9, my a, I'm going to take the square root of 49. Your a is always comes from the first thing that's listed. It won't always have a variable first. What's the square root of 49?
7.
Good. b is the square root of x to the 8th, which is x to the 4th. So my answer is 7 plus x to the 4th. 7 minus x to the 4th. Try number 10. You should have in one parenthesis 10 plus x to the 8th, and in another one 10 minus x to the 8th. Any questions? Now here on the back, I left a place that we could write in these. They're perfect squares if you wanted a place to have them. Probably know most of those by now. But 1 squared is 1. 2 squared is 4, which means the square root of 4 is 2. 3 squared is 9. 16, 25, 36, 49, 64, 81, 100, 121, and 144. Those are your first 12 perfect squares. So something that I haven't cautioned you to look for, but we're going to start seeing now, is a GCF. So anytime we're doing any factoring, and we're only going to do difference of squares, we're stopping here because of time, but there's a lot of other methods of factoring that if we had more time we would get into. Anytime you do any of those, you have to always look for a GCF first. So look for something that you can divide both of those terms by. So, of the 9 and 36, is there anything that you can divide both 9 and 36 by?
9.
They're both divisible by 9. They are divisible by 3, but 9 is bigger. Do they have any x's in common? Yep, they have an x squared in common. So I can divide by 9 and an x squared. So if I divide out the 9, I'm left with 1 x to the what? 4th, good. Minus, what's 36 divided by 9? 4. And I took an x squared out, so I don't have any left. Good. So when I go to do my difference of squares, I'm picking my a and b based on what's left. My 9x squared, that was my GCF, has to come down and be part of the answer. So my a, I'm going to take the square root of x to the 4th, which is what? X to the 2nd. And then my b is the square root of 4, which is 2. So in parentheses, I'm going to have x squared plus 2, x squared minus 2. And then you cannot forget your GCF. Anytime you have a greatest common factor, something that divides out, that has to be included in your answer. Number 12. Is there a GCF? Yeah. These numbers are not perfect squares, so there would have to be a GCF for that to work. And yes, it is 2. Do they have any x's in common? No. So all we're doing is dividing out the 2. which leaves us with x squared minus, not 32, 16. We're dividing by 2. Yes.
Is there any way we can pull that curtain thing? Because I can't take it off.
Alright, and then my a, I'm going to take the square root of x squared, which is x. And my b is the square root of 16, which is, nope, 4. And so my answer, I'm going to add in the x plus 2 and an x minus 2. 4. Yeah, sorry. Any questions? Number 13. Is there a GCF? What? Yep. You can divide both of those numbers by 3. Do they have x's in common? Nope. So just the 3. Which leaves me with what? Well, what's 12 divided by 3? 4x squared minus 9. Alright, so then for my a, I take the square root of 4x squared. And you just take the square root of both of those, the 4 and the x squared separately. So what's the square root of 4? 2. And the square root of x squared? X. We get 2x. And my b is the square root of 9, which is 3. So in my answer, I'm going to have 2x plus 3 and 2x minus 3. All right, number 14. Is there a GCF? 5. And no x's in common. What's 125 divided by 5? 25. X squared minus, what's 20 divided by 5? 4. Bring down your GCF. I like to do that from the beginning, otherwise I often forget it. And so do a lot of you. And so then my a is the square root of 25x squared, which is what? 5x. And then my b is the square root of 4, which is 2. So my factors are going to be 5x plus 2, 5x minus 2. Questions? All right, number 15. Is there a GCF? You cannot do 100 divided by 8. 4 is the GCF. They are both divisible by 2. If you divided by 2, you would have a 32. 32 and 50 are not perfect. So if I'm asking you to do difference of squares, you're going to get numbers that are. So these are both divisible by 4. Any x's in common? Yep, they both have an x. So what is 64 divided by 4? 16. And then I have an x squared minus 25. And then that x, I don't have that x anymore, it came out. So my A is the square root of 16x squared. 4x. Yep. B is the square root of 25, which is 5. So my factors are 4x plus 5 and 4x minus 5. I want you to try number 16 on your own. Alright, so this one had a GCF of 2x, which left us with x squared minus 9. And the square root of x squared is x. The square root of 9 is 3. So our final answer was the 2x with an x plus 3 and an x minus 3. And we'll stop there.